So we're back, our second video. We had been talking about field of view and magnifying things by 100, from the park bench that we started at to maybe Morristown, to the region which encompasses the Susquehanna River, there's the Delaware, and then we went to planet Earth, and here we're at 100,000 times a park bench, and basically. And then we went to another 100 out and went to the Earth and the Moon and quite a bit of space around it. That's 10 million times that park bench, basically. And then we went out to what's called an astronomical unit, an AU, because we're getting too unwieldy with these units here. 10 million times a park bench. It's crazy. We can call this one astronomical unit, an AU, the distance between the sun and the earth. For hundreds of years, this was a very important unit. We're going to talk about that a little bit more. If we went up and expanded this more, that was our last video. If we went out and expanded this more and gave another 100 times the field of view, we would see the rest of the solar system. Now look here, you can't even see the Earth at this point. You can barely see the sun, but we can get all the way out to Neptune, and the Pluto, which is no longer a planet, is in there too. That is 100 billion times the park bench. And this is basically our solar system. What is a solar system? A solar system is a system around a star. It is our star system. Take it on another 100. And you are at 10 trillion park benches. And we are now seeing nearby stars. We had talked about the fact that our closest star is, if the sun was a grapefruit, the closest star would be a grapefruit in San Francisco. Now we see there's that Alpha Centauri in this view that is 10 trillion park benches away. Long way away. That star takes, the light from that star takes 4.2 years to get to Earth. Kind of crazy. If we went out again 100 times that park bench, we would finally see our galaxy, the Milky Way. And that's 1 quadrillion park benches. Let's examine a little bit more about what we just described. So we had an observation. Let's apply some things to it. What is a galaxy? You know, we just looked at the Milky Way galaxy. Let's explore it a little bit. This is the Milky Way galaxy. You see it on beautiful nights when you're out, especially in the western areas of this country where there's very little light pollution. You can see it crossing the entire sky. And the Milky Way is so huge that it crosses the entire southern hemisphere side and northern hemisphere side and far beyond. But we can see the Milky Way, and we can see part of the central light of the Milky Way in our galaxy when we see the brightest part of the Milky Way. And what this galaxy that is surrounding us, here's where we are in this galaxy, the location of the sun and the earth, our little solar system is part of this galaxy. A galaxy is a massive, meaning mass, an amazing amount of mass or matter, a massive island of stars in space. These stars are held together by gravity. We'll get into that soon. All of these gravitational stars orbit a common center. This is the common center. Sometimes you can see that at night. The Milky Way galaxy, our galaxy, is just an average size galaxy. The number of stars we don't even know, but we're looking at somewhere of the order of 250 billion stars, plus or minus 150 billion stars. Amazing. Sometimes, especially out west, you can see this This is the center of the Milky Way galaxy. A beautiful look. This will move all the way down to the southern hemisphere, all the way up. These are other galaxies that orbit our galaxy, and we're just an average size galaxy. Our average size galaxy is about 100,000 light years across, meaning that light from one edge of our galaxy, our Milky Way galaxy, takes 100,000 years to be seen on the other side of the galaxy. And we'll go over how fast light is. It's amazing. So we'll talk more about this. I just want to introduce the idea of galaxies. If you want to see the nearest galaxy to the Milky Way, and it's the only one you can see from the northern hemisphere, you can actually see it on moonless nights. A great time to do this is on September 16th, which is coming up. So when you go outside, look to the northeast, and you can often see a W in a constellation. That W is Cassiopeia. Or you might see a box over here. The box is Pegasus. And then when you see the W or you see the box, look for in between, look for the graceful lines of Andromeda. And above the graceful line, you will see the Andromeda galaxy. It is a cloud. It looks like a cloud. It's been seen since 900 AD by Persian astronomers. Islamic astronomers really brought us into the Renaissance. And this was one of the things that they identified. The light from this galaxy, which is twice as big as our Milky Way galaxy, the light from this galaxy takes, listen to this, 2.5 million years to get to our Earth. It's amazing. 2.5 million years to get to our Earth from the Andromeda galaxy, and you can see it if you went out on a moonless night in about a week. Now, we talked about moving a little bit even farther out by 100, and when we do that, we're way out from our Milky Way galaxy, and we're seeing clusters of other galaxies around us. Like the Andromeda galaxy is one of 28 galaxies that is closest to us. I don't think you see 28 here. This is about 100 quadrillion park benches. Okay, a lot of park benches. And the galaxies tend to be seen in clusters. That's what we know from the Hubble telescope. If we go out another 100, we're at 10 quintillion park benches. And we see networks of superclusters of galaxies. This is not a supercluster. This is just a cluster. Then you get to superclusters. Then you get to networks of superclusters. This is what we believe from Hubble, and this is the only thing that we know at this point. Let's describe that a little bit more. What is a universe? We're not even sure what a universe is. And what we think a universe is, it is the total sum of all matter and all energy. All the galaxies, everything in between. Our best telescopes have not seen the edge of the universe. Our best guess is that there's 200 billion galaxies in the universe. And Hubble will actually go down and start to disintegrate in this year and is going to be eclipsed by the Jack Webb telescope, which is supposed to go up. It was supposed to go up in 2019. It didn't. It's supposed to go up in 2021. And that should be amazing. I've actually seen part of the museum that discusses this down at Goddard in Maryland. It is fascinating. Great museum if you ever get a chance to go down there. So we'll talk about that more. And what we want to talk about is, all right, we're at 10 quintillion park benches, but not really, because we have more space than just this park bench. 10 quintillion is 100 times what we looked at, and we looked at it 10 times. We're looking at this exponentially, right? It's not 100 times 10. That's additive because multiplication is sequential addition. No, this is sequential multiplication. It's an exponent. So don't get freaked out by that. That's okay, right? So we're going from this park bench and its area around it to 10 quintillion areas. So we could say it's how many feet? How many feet would it be? Well, if it's 16 meters here, and that's basically 52 feet, we can say 52 feet times 10 quintillion equals 520 quintillion feet. All right, that's it. But you don't really want to deal with feet. You'd rather deal with miles. And that gets very complicated because then you have to use a conversion factor because 1 mile is 5,280 feet. This gets really crazy. And then you know that you can cancel out the feet with a conversion factor because feet over feet can be canceled out to just equal 1, right? And that way you get 520 quintillion miles divided by 5,280. That's just crazy. We're not going to do that. We're not going to do that. That's crazy. That's going to lead to mistakes. That would lead to mistakes for anyone because it's all fractions. And who likes fractions? Everyone hates fractions. We're going to get rid of the English system. We're going to go to metric. Yes, we are. And we're going to go to metric because it is in orders of 10. You just move that decimal point. So let's go to metric. All right. And in going to metric, I'll show you that we would take the same thing. This is 16 meters. You multiply the 16 meters times the 10 quintillion. You have 160 quintillion meters. And you don't want quintillion meters. You want kilometers. So when we go to the metric system, we're going to be working with kilometers, which is just a unit of 10 based on units of 10. No fractions in here. And we are going to say that, look at this. It's beautiful. 1,000 meters equals 1 kilometer. So look, I can divide it by 1,000 meters. I can take off all those zeros. Boom. Then instead of 160 quintillion meters, I have 160 quadrillion kilometers. Still too much. I need something much more than kilometers. Okay, well, you talk about gigabytes in technology. Okay, we can talk about gigameters. A gigameter is 1 billion meters. So look at this. If I have 160 quintillion meters, I could just take off all these zeros by doing that division. And look at this. I have got 160 billion gigameters between the park bench and the entire universe. Well, this is getting a little bit better, but it's still not good enough. So let's keep looking at it because you like terabytes. I mean, my son loves terabytes. And a terabyte is, let's just look at it here. Here is thousands, millions, billions, 1 trillion meters in a terabyte. Just remember the T, trillion, terabyte. Okay, you can do that. 1 trillion meters in a terabyte. Look, you can take off all of these zeros when you do the division out with the conversion, and you're left with something that's manageable. Here's the ones, here's the thousands, there's the millions. We're left with 160 million terameters. Well, that's actually getting to something that we may not make mistakes on, but we may make mistakes on it. So we're going to talk about something even easier that's added on to this, scientific notation. And when we talk about this, keep in mind that astronomy is the science of big numbers, so we're going to make it as simple as possible to avoid mistakes. I'll see you on the other side.